Hello? Hello? Hello?
So please start. So sorry, I was introducing you, but I had the mic muted. So
no problem. But do you see me and well, yes. More important, the presentation?
Yes, it can.
Okay, then let's start with temporary ventilation of rail tunnels during refurbishment works. So welcome everybody to this presentation. So the purpose and focus of this presentation is to give you some examples of recent developments of temporary ventilation. So I will start off with objectives of temporary ventilation, then the challenging tasks of ventilation in rail tunnels during refurbishment works. And then that's the main part. I will come to some examples of recent developments. So we will hear about wetting of ballast, fixed and mobile ventilation, ventilation from portals, mobile air cleaning, monitoring for control and documentation, and simulation tools. So that's the content of this presentation. I will start with these objectives and objectives of temporary ventilation in a wider sense, so including cooling or air cleaning. The objectives are to comply mainly with occupational health requirements. Then, of course, we want to assure functionality of machinery, support during incidents, and then that's the key requirement or key complication. We do want to interfere as little as possible with the actual refurbishment works. And then we want to allow simultaneous operation of infrastructure, either full-time or during time slots. Now, this translates into the following tasks. We have to supply fresh air. We have to extract waste air. We have to control smoke propagation if possible. We have to clean air, for example, by dedusters or filters, humidifiers, and we have to extract heat by air exchange or by a dry cooling system. Now, the challenge of refurbishment works in rail tunnels is that first of all is the amount. So there are many railway tunnels to be refurbished. Then typically there is no permanent ventilation system installed. This is different to road tunnels. Often there is a small cross-section and limited space available at the portals, as you see here on the pictures on the left. Often we do not have power supply in or at the tunnel, and there are increasing demands on air quality and health protection. Now, these challenges are illustrated a bit for examples in Germany. So here, for example, from 2019 to 2023, about 80 first-generation high-speed rail tunnels have to be refurbished. This sums up to about 155 kilometers of mostly twin-track single-tube tunnels with ballast track. Those tunnels are then taken out of service for a couple of months, so certain sections of the lines are not operational then. And of course, there are several other older tunnels to be refurbished. So this is a challenge in terms of quantity. And the other challenge is the increased demands on air quality. In 2019, a directive of the German Federal Railway Authority was enforced, and the particular focus of this directive was to protect against dust. Dust was identified as, especially from ballast, as possibly cancer causing, and so strict limits on dust are now to be respected in the refurbishment projects. So there are now limits on respirable dust, on fine or alveolar dust, and quartz fine dust. You see the limits here given as well on this slide. Of course, there are many other criteria to fulfill in terms of air quality. I'm not going through all of them. The important thing to note here at this point is that all these criteria have to be fulfilled, of course, and to confirm this or to provide evidence, you have to monitor them online and constantly doing all kinds of maintenance works or refurbishment works to be done in the tunnel. So it's mandatory now to provide documentary evidence on the fulfillment of these criteria. Another part of this directive was that it's now mandatory to wet ballast of tracks before and during the works in the tunnel. And this is the first example I like to show here, the first of these 7 examples I was talking about at the beginning. So now, because of this directive, it's mandatory to put 30 liters of meters per square meter on old ballast to be removed by an excavator. So that's now required. Here at the top left, you see an image where this quantity is measured. This was just for test purposes to see the impact, but now it's mandatory and has to be documented that you bring in certain quantities of water in on the existing old ballast before it's taken out. Here is another requirement. So you have to water or wet new ballast with 10 liters per 1 ton of new ballast. You see that an example of an outside installation. So the ballast, before it's being brought into the tunnel, is wetted by water. And at the bottom 2 pictures, you can see the difference. So this wetted ballast releases much less dust than before in former times. So that was the first example. Coming to closer to the actual ventilation, we see here the various options where to put the fans and diesel power generators without impairing with the works. These are principal options, so you can put them on the work track or on the open track to be provided for construction site or refurbishment site logistics. You can put them as well outside the portal or outside the tunnel. And all these examples, are in principle possible, but only a few of them are really reasonable depending on the boundary conditions. And we will come to those now. So here, the second example is about fixed ventilation for longitudinal ventilation. This concept of ventilation is often applied now for these high-speed tunnels. They have a large cross-section. It allows to put fans, jet fans on the lateral sidewalk. And typically there are 2 groups, one group, or yes, at each portal, there is a group with a separate diesel generation, power generation. And these 2 groups, they first of all provide redundancy. So if one group fails or generator fails, we have always a spare capacity, 100% spare capacity. And as well, it allows to switch off that group where in the proximity of work. So this then reduces noise and airflow exposure to the workforce. So that's the fixed ventilation. Another concept is the mobile ventilation for longitudinal ventilation. These are examples from Switzerland. To the top left, you see a particular solution for the Simplon tunnel. Here, a major fan blows air into a tunnel leg. The fan is sealed off to the tunnel wall by an inflatable belt. And so by this, we can create a longitudinal airflow. Power supply is from the catenary or from the traction power supply. At the bottom, you see 2 examples of jet fan cars with integrated diesel power generation. The left one has been used already since a longer time. The right example, the yellow car, is now a prototype and it's being tested for application. Swiss Railways have decided to buy 8 of those cars, especially for short-term interventions, and you can combine a couple of cars of them to increase as well the ventilation power. So 8 of those cars are now being manufactured. So these are examples of mobile ventilation. If it comes to heavy works in a tunnel, so where a track is completely replaced, then there is a certain limitation where to put those mobile fans. One track has to be kept passable for the construction site or refurbishment site logistics, and on the construction track you can put this mobile fan then only outside and blow into the tunnel, or you can put this fan and diesel generator inside the tunnel to draw out the air. So these are the options of putting them in this tunnel. Other examples of mobile ventilation are shown here. So to go with such a vehicle or to go with a fan, there are crawler mountain jet fans now developed with diesel power generator. These are examples from North America. Or another concept would be to place the fan plus diesel generator on a platform, and this is then placed by a crane onto the work track or work track area. So this is a quasi-mobile ventilation then. A fourth example of recent developments is this ventilation from the portals. So jet fans are blowing from outside into the tunnel. There are no ventilation installations in the tunnel, so there is no interference with the track works. This allows independent contracts and responsibilities. However, it requires space at the portal and more powerful jet fans are required. So you see here three tunnels, three different examples how that was realized in projects. A fifth example shows the mobile air cleaning. So here an air filter is an integral part of a track renewal train. So this concept was tested before, but to this extent, it's a recent development. This was applied for the first time this year in Germany. And so here air is extracted at major dust sources of track renewal and then filtered inside the tunnel. So this is sort of beating the dust at the source. The sixth example here I'm showing of recent developments is related to mobile monitoring, control, and data storage. So as I said before, now we need to document the sufficient air quality. For this, we have now more and more remote control of ventilation equipment. This allows as well to provide documentary evidence of the compliance of the air quality with the requirements and can be used by the contractor, by the client, and by the authority. It as well allows to provide adjustment of the ventilation power to the needs. So this can be named as ventilation on demand adjustment. Okay, this was my sixth example, and now I'm coming to the last one, and that's about simulation tools for temporary ventilation. So some tunnel networks get quite complex, for example, metro networks with stations and so on. And so sizing and performance evaluation of the ventilation must be done or are easier done by simulation. It allows as well to cover and address all the various work stages which might appear in such projects. So here to the right, you see an example of complex ventilation, and you see at the left bottom, as well an example of a typical tunnel element, which constitutes such model to consider all kinds of aerothermal and pollution aspects, and you can combine those elements then to networks. This is shown here in an example. It allows as well to investigate networks with time-dependent domain or extent. So increasing tunnel length also can be addressed here. You can as well investigate refurbishment scenarios and phases. And of course, you can confirm all aspects of performance regarding different thermal conditions and air quality. And finally, it allows as well to do some kind of incident analysis, so smoke propagation, for example. Now, this was the last of these 7 examples. I come already to the conclusions, and they are given here. So temporary ventilation during rail tunnel refurbishments must cope with a variety of requirements and boundary conditions. For safe and healthy work conditions, each project requires individual solutions, and an increasing complexity of tunnel networks requires dedicated simulation tools for design of temporary systems. So thank you very much for your attention. I hope it was helpful and illustrated a bit recent developments. Thank you.
Yeah, thank you very much, Peter. So very nice and informative presentation. So I had a look on the discussion forum, and up to now I cannot see a question there. So please allow me to ask a question from my side. As I have seen it on your presentation, you mainly blow the dust and the air throughout the whole tunnel cross-section. Is it also used, or is it common to use air ducts to suck off the air and also the dust, so that it can be handled outside in a dust removal plant?
Yes, there are examples on that approach as well, especially, for example, in metro stations or systems like that. So in urban area, you do not want to release, dust burden air to the outside. So there are examples where you put those filters outside the tunnel and bring the polluted air to those filters, by air ducts. There are a couple of examples, of course, as well. The most simple approach, of course, is just to provide a longitudinal ventilation. And if it's not in urban area, there is no aspect of, how should I say, of considering the vicinity.
Peter, there is another question from Nathaniel Tan. The question is, on the ventilation fan and diesel generator on a rail vehicle, even if we couple multiple units, we may get more power, but not necessarily better airflow. Have there been any studies into this aspect?
Well, of course, those jet fans, maybe I go quickly back, those jet fans, they work only if you keep them individually apart. So you would need to place, a certain distance between each of, for example, this yellow car shown at the bottom right. And then sort of there is a superposition of these different fans. Maybe this answer is too simple, or it depends on the individual case or individual problem. But in principle, you can add on the power of different fans to create as well sufficient airflow in very long tunnels, for example.
Okay. And then there is a question from Twan van der Slikke. And the question is, what is your experience with ionization?
To be honest, I cannot really give a reasonable answer. I can only say that this is not typically applied in a common rail refurbishment project, but I'm only talking from my limited point of view of, what I have seen as projects in Switzerland or in Germany or in Austria. So perhaps there might be possibilities to use ionization for air cleaning as well. But on typical construction or refurbishment side, I'm not aware of that concept to be applied.
Okay, thank you very much all for joining the session. So the session will end in about 25 seconds. So once again, thank you very much, Peter, for your very informative presentation. And I hope to see you all back in the next presentation, which is on the refurbishment on the huge Haerter tunnel in New York City. See you there. Thank you.
Okay, thank you.